Hi everyone, welcome back. In this video we are gonna learn about Cv-Cuda and also we are gonna install it in our local machine. But basically what it is, this is also a library, a tool which is developed by NVIDIA, and in the backend it still uses CUDA language, CUDA kernel language. So in my YouTube channel also you can find the CUDA usage, kernel usage example, but this is more optimized way, and also it's even in the behind it's still using CUDA kernel part, but it's giving the functionalities what we actually need as computer vision engineers. So this is a very useful tool, and it's not known well in the in our environment, so we can check this and we can install, and in other videos I want to make example based on this library also, because this is using very efficiently the GPU for the purpose of the image processing and AI computer vision applications as said in here. Okay, so use cases you can also check here: generative AI, 3D worlds, HD mapping, and also of course image understanding. And here my target is based on C++. The usage in Python is I think the easier, at least to be able to get the result faster, but we are gonna focus for the C++ part. We can go to the GitHub page. Here is the one. So all I want is firstly just installing this, so we can go through to the part which we are interested, build from source. So we need this one, and here so first of all you need to clone it. Actually I already got this, so I want to make it from scratch with you. So just extract here. So we got our repo first of all, then it says just enter to the repo and run this init repo sh file. Let's do that. So I want to go to projects, and CVCUDA. Okay, here. So it says just run init repo sh. Okay, what it says? Okay, so since I didn't clone it from the I didn't clone it with in normal way, so I just downloaded it. It complains. It's normal. Okay, just go to F1 page. Just okay, git clone. Where is the command? Okay, give me the command. Let me get it faster. Okay, while it's done, after that these are the required dependencies. You can check here. By the way, you need to be already in your machine. There should be a CUDA toolkit available, so you can check my also again CUDA installation video if you do not yet install CUDA. And once it's done, since we are using on Ubuntu and 22 my machine version, so I had to run this one. And let's see. Okay, so it's done. So first of all, but we still didn't make this init thing. Let's try now. Yeah, now it's working. So we got the issue together. You need to clone, otherwise it doesn't work with the downloaded version. And hope this faster. Yeah, then the next I need to copy this installation things. And okay, okay, let's try. And after that, do not do these commands. I already warned this in my CUDA installation video as warning. And it says tested. Okay, this is tested with 11 and 12 version. So we have 12 version of the CUDA, and it just says you can install with these commands, but I do not suggest, because we want to use C++. These commands are dangerous. Go to my installation video if you don't have them. Don't do those. Okay, build steps. We don't need this actually. We can directly make and continue it. So make the build. I'm wrong. Okay, just build, and after that just enter build and cmake. Okay, we can go on this way, so we can get the libraries and the other include things inside our build, so we can use them for our C++ example I'm gonna do. And next we can make so you can check your core number. I have 16, so just make 16 here and it's gonna start. I'm not sure how this is gonna take time. Let's see. If it's taking long time, maybe I stop the video here, then I continue after it's done. Yeah, maybe it's gonna take long time. See you after this is done. So build is done. Actually now we already got our libraries, and now next is I want to test this CVCUDA library if it is working fine or not. The best way is trying an example. So let's create a CPP file into here, but not here, it's better in this folder. So touch test.cpp. Let's go to the CPP file, and all I want is creating a simple resize operator object. So if it is working, it means it's initiated, is installed well. And CVCUDA and operator resize. I also don't actually very well know usage of this resize, but at least I know how to initiate it. So IOStream4 if we want to write something to the console, and let's create main, and next like this, return 0, and here just CVCUDA and operator resize, I think, resize and resize operator. So if this is working well, it means we installed CVCUDA correct, not installing but building. Yeah. So it means we can use any functionality of CVCUDA because it means it's installed. Next, go to the here and clear. What I want is, let's see directly what error we got so we can fix together. Like output executable is gonna be okay. So yes, first of all, it cannot find this operator resize. Let's find it, operator resize, which is in here. No, include we need operator resize, this one. Okay, so we need to add the include file and the libraries into here accordingly. First of all, let's start with include. Here let's address the correct place, projects, CVCUDA and source, and CVCUDA include, and CVCUDA is no need because we already give that. Also we need to give the library path, which is I think inside the build folder should be. So here I can copy here, I think. Here I need to give this path, and for now it should be done. CUDA runtime. CUDA runtime. This is related to a CUDA, of course, because at the beginning I said this is required. CUDA is needed. So now in the kernel part, in a function, operator resize header is searching CUDA libraries. So we need to give them. Normally, let's open a new folder. Normally, if you didn't specify a specific folder, it should be installed into the user, local, and CUDA. So all we need is this include and the libraries. Here we can copy this and give it to the command apps. So this is like this. And also we need to give the library path, which is like this one. Okay, let's try again. So now what else? Image batch. So operator resize is searching something from image batch header. Let's go again into here. So search for image batch, which is inside and include, it should be this one. So source and VCV source include, source and VCV source include. So we need to give this include path also. Let's go again. Project CVCUDA source and VCV, and then source again, include. Okay, now it's done. Did you mean resize? Operator resize. Okay, resize should be. Then what's next? What it says, defines reference to NVCV operation, CVCUDA resize, CVCUDA. Okay, let's try to give that library externally, CVCUDA, like this. What now? Lib NVCV types shared object. Lib NVCV types. So we can give that also, NVCV types. Is it correct? Yeah. Now we got our output executable. Where is that? So here. Now let's try to run it. Of course it's not gonna work. Always something comes up. Lib CVCUDA. Where is this? I think it should be inside build. Okay, so I think we need to give this as LD library path. So just export or LD library path is equal to, which is here, and something like this, path. Now do you work? Why? Okay, now it's working, but I just want to get something here. Successfully initiated. Okay, if we see this message, it means it's totally fine. Let's rebuild. Okay, output. So successfully initiated. So it's working. That's great. But it's good. I'm happy because we fixed the issues together, and most probably you will get the same things. And the most difficult part, if you try to do this in your local machine, you need to have CUDA. It's very important, and CUDA installation is a bit confusing. You need to check my other video, but after that these things are solvable things. So yeah, we fix together. And in the next videos, my plan is that since this is a very comprehensive library, we can check other things, other abilities of this library, so we can check, we can make examples together. Thanks for watching. See you in the next videos.